All right, everyone. Welcome back. Same procedures as before. Let's take a look at Tech Math 1, Chapters 3 and 4 review. Last time we were together, we did Chapters 1 and 2, Tech Math 1. Tech Math 1, Chapters 1 and 2 review. Now it's Chapters 3 and 4, as we can see here. All right. Let's take a look at some of these. Let's run through them. For number one, they're asking a question like this. I think they're asking you to solve for a particular entity here, and the way they got it written down here. So you got 3p over 8 equals 1. Multiply by 8 on each side, and you get this, right? Divide by 3 on each side. You got that, right? So what just happened here? Basically, you took each side and you multiplied by 8 on each side. That canceled. There's where you got your 3p. 1 times 8 is 8. From here, you divided by 3 on each side and you got to where you're going to go. 2, solve for x as it is shown. X equals 3x minus 1 over 4. I'd take this, and I just multiply by 4 on each side and see how it's going to play out. Put that within parentheses. Here's your 4. Multiply by 4 on each side. It's going to cancel. 3x minus 1, in parentheses or not, that's not a big deal. 4 times x is 4x. And what do we got? Well, we got a number of things going on here. So (4x) is 4x. Number of ways to do these guys. So, I mean, that's not set in stone that way. Here's 4x, 3x minus 1. Minus 1 is plus a negative 1. Let's play the game. Let's add a negative 3x on each side or subtract positive 3x. Doesn't matter. Subtracting positive 3x is the same as adding a negative 3x. 3x and negative 3x is nothing. Here's your negative 1. What's 4x and negative 3? It's 1x. 1 times x is x. And there's your answer as well. So number 1 was p equals 8 over 3. Number 2 is x equals negative 1. 3. It's a little more convoluted, but it shouldn't be too bad. (2k) over the quantity. So we got this. Well, okay, sounds good to me. How are we going to solve that? You got 2k over 3k minus 1. A lot of ways to go here. Let's just try to give myself a little bit of room. You might see where I'm about to go. Let me get rid of this denominator. Let me multiply by 3 times the quantity, k minus 1. You can do that. The whole piece can be like that. Not a big deal. And you can do the same thing here. This is 6. So, all right, guys, I hope the power didn't go on this. Okay. So 3 times the quantity k minus 1 on each side. All of this, all of that cancels. You got 2k here. 6 times, this is very, very important. You can distribute this inside of here and be done with it, and then take the 6 and distribute it across all of that. Or you can bring the 6 inside and hit either this whole quantity, which is a bit awkward. Better scenario is have the 6 hit the 3. But you do not hit both of these because it's a multiplicative entity entirely. I know somebody might say, what are you talking about? There's a minus right here. There is, but it's within parentheses, so it's not the whole entity right here is a whole piece of a number. This is a whole piece of a number, and it's a straight out multiplication going on. So don't make the mistake of taking the 6 and then hitting the 3 with the 6, and then taking the 6 and hitting all this. You can't hit both. You hit one or the other. So the best way to do it is, and I'm going to show you twice on this. It's pretty important. This thing right here, let's take a snapshot of it. You could say, okay, he said, let's just look a snapshot at the far left here, see what's going on. If you look at what's going on inside, please go ahead and do this. Minus 3 is plus a negative 3. That's fine. Now take the 6 and go here. 6 times 3k is 18k. 6 times negative 3 is negative 18. Okay. That's going to be what's coming down over here. It's going to be 18k plus a negative 18k. Forgive me, 18k plus a negative 18. You're not done, but you got to here. Okay, this works. This is true. You also could have done, rather than this, be extremely careful. You also could have done this. Let me bring the 6 inside and hit the 3. 6 times 3 is 18, and now I got this. Let me distribute the 18, and I got this. Make that plus a negative. Okay. Yeah, you better be getting the same answers. Mathematicians better be getting the same answers every time they do something, regardless of how they do it. If there are numerous correct ways to approach something, they all should be giving the same correct answer, regardless of the methodology. If you're getting different answers, there's something wrong. And, don't build that bridge. Don't build that airplane. Don't build something that's going to endanger that medical equipment is going to endanger other people. You have to have this thing in agreement. Notice I did 2 things here. I did the distribution right off the bat inside of the brackets and got it to here. Then I did distribution again and got that. Here, this whole big entity is left alone and say, okay, don't take this and hit both of these. Just hit one. If it was straight out addition and no multiplication otherwise, then you can take all of it and take the walk like that. This is hugely important. You don't do distribution. I mean, if I say to you, I don't know what to say. I mean, if I say H times A times B times C, that H can come inside and hit the A, and then you're done. Leave the B and the C as is. Or have the H hit the B, and then you're done. Or have the H hit the C, and then you're done. These are all correct. These are correct. This is the correct answer. Do not ever take the H, hit the A, take the A, hit the B, take the A, hit the C. No way. The only time you're hitting all of them is if there's addition. Absolutely, absolutely, at this point, it's HA, HB, HC, and you're adding them. No doubt, that's true. Not in an instance like this. In an instance like this, it resembles this scenario, where this is an A, this whole thing is an A, and this whole thing is a B. Even though there's a minus in there, the parentheses make it one big chunk, one big number. Be aware of that subtlety when you're doing mathematics. Be aware of when you can distribute and when you cannot distribute. I've gone into that in other films. In fact, I went into it, I think, in the last film that we just did, Chapter 1, Chapter 2 review pertaining to this material. I think I've done it before that as well. And in person, you'll see me do that. So be cognizant of that. And, without further ado, we're not done with this problem, guys, but I think we did have to take an important segue, I think. We got this. We got this. All right, we got the setup. Let's take this thing to the end. So we did what we had to do. So we're looking at it. I mean, 18k plus negative 18 equals 2k. So let's go. Let's get the 2k's over to one side. Let me add a negative 2k on each side. We know the drill. Add these together, you got 16k. These together, you got 0. Add a positive 18 on each side. Out of there. You know where I'm going. Divide by 16. I don't know. 2 times 9 is 18. 2 times 8 is 16. Should be the final answer. K equals 9 over 8 for number 3. Let's keep going. I mean, it's just, some kind of, for problems 4, 5, 6, and 7, they're going to kind of be very similar or have a lot of similarity, for lack of a better word right now, to problems 1, 2, and 3. So let's do problems 4, 5, 6, and 7 and see where that is. All right, let's look at something like number 4. I mean, I said there's a number of ways this stuff can be done. I can't show you all the ways sometimes. Time doesn't really permit it. But if you got something like this, equals 4, that's number 4. Let me try to give myself enough room to hit a few of these at least. 5 is saying f over f minus 1, 3/8. And 6 Okay. I mean, I'm looking at this. I'd probably look to get rid of the denominator, and there's a number of ways you can probably pull this off. Really a number of ways you can do this. Let me show you one of the ways. 1 minus 3 over 4w. Minus 3 over 4w is plus a negative 3 over 4w. Watch this. I'm going to subtract 1 on each side, or add a negative 1 on each side. That's out of there. That's 0. I got negative 3 over 4w. I got negative 3 over 4w equals 4 and a negative 1 is 3. Okay, we're not done, but we got to there. Looking pretty good. A lot of ways we could go here. Tell you what, I'm going to multiply by 4w on top on each side. 4w cancels. You got negative 3 right here. 3 times 4w, 3 times 4 is 12. Bring the w around for a ride. You don't distribute in there. We already said that. If it was 4 plus w, yeah, the 3 would distribute to the 4 and to the w. If it was 4 plus w or 4 minus w. But not when it's this, straight out multiplication. You hit it in one of the places and you're done. Here's one place. 3 times 4 is 12. You got it right here. Once you get to here, divide by 12 on each side. W equals negative 3 over 12. We know where this is going. Negative 1 times 3 and 4 times 3. Right. And there it is. And there's your answer. So that was number 4, negative 1/4. What about right here? Nothing wrong with putting parentheses around an entire entity that is in a fraction format, that is in a rational expression format. The f minus 1 can be made the quantity f minus 1. Sounds good to me. There's a number of ways this can get done. They've got this thing called cross multiplication. If you got a over b equals c over d, sounds good to me, you can say the following. Is it true that if I multiply both sides by, well, here's a b, here's a b, here's a d, let's multiply by bd on each side. It's still an equation if I do that. The b's cancel. You got dA. The d's cancel. You got CB. That's the same as BC. This is AD. You know, this is all aesthetics, but maybe it's easier to remember. BC equals AD. How did that happen? BC equals AD. Why don't you they got this thing called cross multiplication. You make an X. B times C is BC. A times D is AD. That's called cross multiplication. That's not cancellation. When you're doing cancellation, don't call it cross multiplication. This is cross multiplication. And look how it is. Look how it works. Kind of neat. Well, if that's the case, I think it's probably your easiest way out of it. It's not the only way out of this thing, but it might be the easiest way out of it. 8 times f, 8f. 3 times f minus 1 is this. That's all it is. Remember, it was like a over b, c over d. BC is BC. AD is, or rather, right, AD is the AD here. Very important. The cross multiplication is a good way to go. Kind of get everybody going horizontally here. You get rid of these guys being in the weird situation that they're in. This is a -1, which is the same as plus a -1. That's your business if you want to deal with that or not. Just get the right answer at the end, you guys. Here's 8f. 3 times f is 3f. 3 times -1 is -3. Okay. Looking pretty good. Look, let's kind of cut to the chase, you guys. Let me subtract 3f on each side. Or add a -3f on each side. 8f and -3f is 5f. 3f and -3f is 0. That stays -3. This and this is 0. That stays -3. 8f minus 3f is 5f. Sounds good to me. 5f equals -3. So let's just give ourselves a little more room. Divide by 5 on each side. F equals -3/5. Sounds good to me. Let's see here. F equals -3/5 for 5. You got it. 6. We are saying this right here. Probably a common denominator is a good idea, but you don't have to. Here's a 2. Here's a 3. 2 times 3 is 6. Multiply by 6 all the way across this thing and see what happens. Basically, there's nothing wrong with putting things in parentheses if you do it correctly. Parentheses or brackets. It's fine by me. 2 times 3 is 6. I'll tell you what, I'm going to multiply by 6 on each side. If I do the same thing on each side, it remains an equation. Here goes. 6 is the same as 6 over 1. Just for place value here, guys, if you don't mind. 6 over 1. This one is 6 over 1 times 3p over 2. The subtraction will not be dealt with until the very end. And 6 times 1 is 6 times 1. All right. See what happens. The 3 and the 6 cancel. You got 2 right here. There's 1s on the bottom. 2 times 4p is 8p. 1 times 1 is 1. 8p over 1 is 8p. 2 into 6, 3 times. 3 times 3p is 9p. There's the minus that we haven't really dealt with yet, but we had it there just holding our place. 6 times 1 is 6. There's a lot you can do here. There's a lot you can do here. If you get to here, minus this is plus the opposite of that. Negative 9p and positive 8p is negative 1p. Negative 1p equals 6. Divide by negative 1 on each side. We divide by the exact same number on each side. P equals negative 6. And there's your answer. That's all the way through. That's all the way through problem 6. Let's go to problem 7. They all kind of have there's many problems that have a very similar look. And in the first 6 problems, we saw that. We're going to see another problem which will be very similar to the first 6. They got kind of a certain look to them that's got a lot of similarity with one another. Okay? All right, if this is the case, All right, let's keep going. 7 is asking, so as I said, guys, there are patterns, and the patterns are pretty straightforward. We need to know the basics of the mathematics that we're talking about. Okay, looks good to me. What are we going to do about it? Suppose there's a number of things we can do about it. I'll tell you what, I think probably the easiest way to do it is get rid of all fractions. Now, you can do a lot of things with fractions. If you're adding them, you need common denominators. Usually when you're solving equations, getting common denominators, or many times when you're solving equations, getting common denominators is not the most pressing issue. A lot of times, if you multiply by the same thing on each side and get rid of all fractions present, that's the easiest way to go. Sometimes don't even deal with the fractions if you don't have to. Multiply by something on each side. Now look, we already know for this equation to be true, h cannot be 0 because 2 divided by 0 is undefined. 2 times 0 is 0. 3 divided by 0 is undefined. So h can't be 0. If I get h equals 0 in this problem, it's not really valid. We already kind of know that. We picked up something, they call them extraneous solutions. Extraneous solutions are solutions that get picked up in the process of solving problems, but they're not valid into the original equation. Things have to be valid into the original equation. Tell you what I'm going to do. This is h, this is 2h. I'm going to multiply by 2h on each side. This is h right here. This is 3 over 2h plus 7/4. Tell you what I'm going to do. Let me multiply by 2h on each side. Let's see what happens. Minus 2 over h is plus a negative 2 over h. Let's deal with it. Let's go here. Let's go there. We got 5 times 2h, or 2h times 5. We got 2h times negative 2 over h. The 2h is really 2h over 1. It's the same as 2h. Just kind of know where it is. The 2h has got to be on top. Like over here, same thing's going to happen. It's going to go here. It's going to go there. It's going to be 2h over 1 times 3 over 2h plus 2h times 7 over 4. Well, there's probably some other stuff we got to take care of down the road as well, but this is not a bad way to go to get this thing under control. All right. Okay. Well, I mean, let's deal with it. The h cancels with that. 1 on the bottom means whatever's on top is what's going to fly. The 2h, 1's on the bottom. The top is what goes. This is a little out there, but we'll deal with it, and we'll get to where we got to go. All right, let's go. Let's go way over there. 5 times 2h is 10h. 1 times negative 2 over 1 times 1, it's negative 2 over 1 is just negative 2. 3 is 3. 2h times 7 is 14h over 4. I mean, not quite ideal, but okay, we can live with it. many ways to go, guys. I don't want to completely beat this thing up too badly, but I'll tell you what. I think for our purposes, and given I don't have an audience directly in front of me for us to kind of feedback with one another, what do you say you multiply both sides by 4? Take this thing a little further. 4 here is 40h plus negative 8. 4 here, 4 times 3 is 12. 4 times this guy, they cancel. What you have here is 40h plus negative 8 equals 12 plus 14h. I'm certainly not done, but I'm here. I got to here. From here, let's subtract 14h on each side, or add a negative 14h on each side, and see what happens. 40h minus 14h (12 is 12). 14h minus 14h is 0. Okay, I'm looking okay. Let me add 8 on each side, negative 8 and positive 8. It's nice to do. Adding's a good way to do things, guys. Add this, you got 20. Divide by 26 on each side, you got this. Yeah, and that's, 2 times 10 is 20. 2 times 13 is 26. H equals 10/13. Problem was that? Yeah, these are a load. I mean, they're easier to do than they are to explain. And there's a lot of steps you can skip, and sometimes we will have to skip steps just to get done with certain things. Or not skip them, but you kind of just explain what they are and just go for it. But that's not always going to be the case. We very frequently got to be pretty rigorous about it, as we have been so far, and that works fine. That was number 7. 14, I don't know where the 14 came from on that. I must have done something. I hope I did not do something wrong. Maybe they're wrong. Maybe I'm wrong. Let's make sure everything is okay. 14, that's 26. Okay, let me make sure, guys. Let me make sure this is right. I mean, we got to here. I'm not agreeing with their answer, and they're not agreeing with my answer. And I bet you they're right and I'm wrong, but let's just check it. If I multiply by 2h on each side, I got 10h plus negative 4. That was my fault. This guy right here coming over, there's a 2 right here. 2 times negative 2 is negative 4. That's absolutely my mistake. So let's try this again. It's the way it is. I mean, things can happen. Let's kind of not throw everything out, but got to throw some of it out, I guess. It's going to happen sometimes. Always check our work, and look. We were up here, and we multiplied by 2h on each side. And that's what we did right here. That's completely right. Multiply by 2h on this side, multiply by 2h on that side. All this is also correct. Everything here is correct. Everything here is correct. This 2 got ignored by me, my mistake. 2 times negative 2 is negative 4. That's the big move. That was my mistake. So right here, guys. those got to be brought together. I just left the negative 2 there. Why would I leave a negative 2 there when I'm multiplying why would I leave the negative 2 there when I'm multiplying the negative 2 by 2? And here's the negative 4. That's the correction. My fault. All right. Let's keep going. 4 all the way across. 40h. Negative 16. 4 all the way across. 12. 4 all the way across. This guy's going to cancel. So we got 14w over 4. Here's the 4 right here. That cancels. Okay, good. We want it to cancel. Then we got 40h plus negative 16. The 4 cancels with the 4. The 4 went over here to get you 12. Don't just cancel the 4s here and think you're done. If there's a plus right here, and there is, or a minus, that guy goes everywhere. It goes here, completely cancels, but stays alive and goes over here as well. Make sure you're aware of that. Fine. Okay. Okay, this should be okay. Let's subtract 14h. Subtract 14h on each side. And we got 26h, over there. 40h minus 14h is 26h. Plus a negative 16. This should get us the right answer. We got 12 right here. And we already got rid of the 14. Let's add 16 on each side. Out of here. Divide by 26 on each side. Basically the same argument as what I was giving when I made the wrong move. But I'm still wrong. Doesn't mean if I have the right logic, I have to pay attention to detail. That's 14 over 13. So let's see here. Okay, guys, I'm going through chalk like it's nobody's business, but that's the way it is. $14 over 13. Absolutely. Absolutely correct. That's number 7. 14 over 13. Okay, just notice, even if your logic is completely correct, one small mistake results in a mistake. And, luckily we caught it. Would I have caught it had I not had the answer key in front of me? It's a good question. There's a good chance I wouldn't have. But we caught it. Those are problems 1 through 7. Let's go, and then again, this stuff will scroll at the end. Number 8, for a pulley, the mechanical advantage, capital M, the wheel diameter, capital D, and the axle diameter, small d, are related by capital M equals 2d over 2, capital M equals 2 times big D over the quantity big D minus small d. When the mechanical advantage is 10 and the wheel diameter is 8 inches, find the axle diameter, small d. Okay, not too bad. I mean, it's a little, like I said, reading this stuff out is maybe the hardest part of the problem sometimes. All right, so we're looking pretty good. We got this thing under control. H is 14 over 13 for problem number 7. So Okay, guys, so what the saying about a pulley here, right? A little bit of some basic mechanical engineering being discussed here for us. What's going on here? For a pulley, the mechanical advantage M, the wheel diameter capital D, and the axle diameter small d are related by mechanical advantage is equal to 2D, 2 big D, over big D minus small d. They don't have it in parentheses, but I put it in parentheses. It doesn't really matter. Sometimes it's useful to do so. When the mechanical advantage is 10 and the wheel diameter is 8 inches, find the axle diameter, small d. So they're telling us this guy is 10 and M is 10 and so the mechanical advantage is 10 and the wheel diameter, big D, that'd be big D, is 8. This is interesting. This is in inches, this is inches, this is inches. Inches minus inches is inches. Inches divided by inches is a non-unit number, is a unitless number. Makes sense that the mechanical advantage would indeed be 10, and they didn't say anything. Be aware of that. Find the axle diameter D. There are a number of ways to go here. I will show you what I think is the best way. I mean, at least mathematically speak. You can, I mean, there's a lot of ways out of the woods here, guys. I mean, with this thing. And, you know, I mean, there's just, you know, I'm tempting to show you a number of ways here. Look at what I just put in green. Big M is 10. And big M is 10. Big D is 8. Not going to worry about the units because we know what the final answer is going to be. We don't, you know, big D is 8, but we don't know what small d is. You could write it like this, and maybe it's a little bit easier to look at. I'd like to give you a more rigorous look at what is going on here, you guys, in addition to what I'm about to show you. But I'm showing you this. This gets us out of the woods. Let's see what happens. 2 times 6, 2 times 8 rather, I'm sorry. Is this. There's a number of ways to go here. You could, right off the bat, put a 1 right here and do what I told you. Cross multiplication. It's not easy either way. 1 times 6, we got that. Let's use the distributive principle. 8 times 10, 80. Or 10 times 8, 80. 10 times D, 10D. Minus 10D is plus the opposite of 10D. Let's subtract 80 on each side, or add a negative 80 on each side. This and this. Can play this a bunch of ways, I guess. Let's just do what we got to do. Let's divide by negative 10 on each side. A negative divided by negative is positive. Wow, those rules never really leave, do they? You got 64 over 10. 10 into 64, 6 and 4/10, which is 6 and 2/5, which is, you know, 32 over 5, which is 6.4, and that's probably, I'm guessing that's probably the best way to write it. That's it. You're done. That's it. You're done. Now, I just want to kind of back up. That's correct. That's the answer. Simple as that. Always got to check, guys. Let's do our best. All right, what is going on here? Is there another way we could have nailed this thing? Yeah, I think so. You know, we got what we got, and it's not a bad way to do it. In fact, it might, what we just did is maybe the most efficient way to have done it. Most, just the easiest way, like, hey, let's get this thing done, let's get it over with, let's get it over with. Fine. Let's do this with mathematical rigor, where we're not plugging in explicit numeric values, but rather leave the variables present. Leave the numerical values as variables. Don't put in the 10, don't put in the 8, but solve for small d. Small d is the answer you're trying to find anyway. How are you going to do that? Well, this is worth it, I think. I mean, to look at it that way. Like I said, let's leave this here. We better be getting the same answer, right? I mean, what's going on here? How would you do this? I got an idea. Let's leave everything in terms of variables. Let's leave all the letters present. Let's not put explicit numbers in there. M is the same as m over 1. Let's go. Cross multiply. Big D minus small d. 1 times big D let me distribute. Let me distribute that M. Let me see what I can do. Let me see what I can do. I mean, it's as simple as that. You got to be kind of careful here how you pull this stuff off. Minus m small d is plus a negative m small d. You know, minus big M small d is the same as plus a negative big M small d. Tell you what I'm going to do. Let me subtract big M big D. All right, looking like that, huh? Got to be a little careful now. There's not an easy way to say this. Maybe there is. If you multiply by a -1 on each side, these two switch locations, and you get a positive MD right here. Tell you what I'm going to do. I'll do a little slower. Minus big MD is plus the opposite of big MD. Leave that as is. Let's multiply by -1 on each side. -1 times negative big M small d is positive big M small d. -1 times 2d is negative 2d. -1 times negative MD is positive MD, appropriate signs included. And put them in some kind of an order here, guys, I guess. There are a lot of, like I said, this stuff is easier done than explained, it seems sometimes. Let's do it like that. Plus negative 2d. Let's just put the order a little different. Let's take this guy, leave it alone. Let's pull a d out of there. You got m plus -2. Here's a big D. Let's divide by big M. And yeah, I mean, m plus -2, m plus -2 or m minus 2, not a big deal. Yeah, there's the end of it. I wonder if I'm going to get 6.4. I better. If you're mathematically sound in your argument, if your argument is mathematically sound, you should be getting the same answer. Again, we were done about 5-10 minutes ago, guys, but I thought it was important to show the subtlety of an argument not involving too many explicit numbers written down. There's not any explicit numeric symbolism written down here. It is just more the letter type numeric symbolism written down. No flat out numbers that we're used to looking at. There's letters in there, another way to look at it. And we got this. I'm wondering if it's going to be that answer. This is a good question. Let's put it in here. Big D is 8. Big M is 10. Yeah, I think we're right. If Big D, if Big D is 8 and Big M is 10, 10 minus 2 is 8, 10 right here, 8 over 10 times 8, it comes out to 8 over 10 times 8. That's 64 over 10. That's 6.4. It better be, guys. I mean, otherwise we better go back to the drawing board. Something's not right. I did this 2 different ways, but both of the 2 different ways I did these had the right mathematical logic. I have to come up with one answer here because the reality that we're looking at is one answer. And it better be the same one answer. And it is. It is. You plug it in there. Number 9. One car travels 10 miles per hour faster than another. When one travels 240 miles, the other travels 290 miles. Find the speed of each car. It's a neat question. See if we can figure it out. These are very excellent questions. The kind you would see maybe on an SAT or PSAT or ACT or something on some kind of aptitude type exam. Okay. So, one car travels 10 miles per hour faster than another. When one travels 240 miles, the other travels 290 miles. Find the speed of each car. Not a bad way to go. Not a good question, and it's pretty interesting. Let's call the fast car R plus 10. The slow car, just R. One's 10 miles per hour faster than the other. When they both, for the same amount of time that they're traveling, time t equals time t in both instances. One is going, the fast one's going a distance of 290 miles at a speed of r plus 10 when it travels for t amount of time. The other one goes 240 when it's going at a speed r, also for a time t. That's it. It's the hardest part of this whole problem, you guys. If you can get the setup to here, you're looking pretty good. This is interesting. If that equals that, if all that equals all that, and all this equals all this, then all that divided by all this is the same as all that divided by all this. If that equals that, and this equals this, then that divided by this is the same as that divided by this. 290, just divide the two equations in the right way. I don't know what t is. I can find it out later if I need to. You're right here. It's a very big move. That's the move to make, right there. The t's cancel. You got 290 over 240. 290 over 240 is r plus 10 over r. Nothing wrong with putting the whole quantity in parentheses. In fact, it's kind of a must in this case. The quantity r plus 10. That's it. Just solve it. Just solve it. 290 times r, 240, right, that's it. The cross multiplication we were talking about. Do the distribution. You got it to here. Subtract 240r. Subtract 240r on each side, or add a negative 240r on each side. $50r. Do this, I got r is 48. If I add 10 onto 48, I got 58. Here are your two speeds, guys. Here's the slow guy. Here's the fast guy, according to the mathematics that we just did. There it is. Again, you got the calculator, you got whatever it is you want to do, but there's where it's at. By the way, how long were they traveling to cover these distances? They're both traveling for the same amount of time. I think it comes out to like 5 hours, actually, in both instances. If this guy, if you're going 290 at a speed of 58, divide by 58 on each side, and you got 5 hours. Well, they were both going for 5 hours. So if you're going 240 at a speed of 48, divide by 48 on each side, yeah, here's your 5 hours again. The mathematics is fully consistent with itself if we're doing it correctly. Nobody asked us how long, by the way, how long were they traveling? Each one to cover the distance that it covered. Each one to cover the distance that it covered, how long were they traveling? For how long were they traveling? For what period of time? For what period of time were they traveling to cover the distance that they traveled? 5 hours. 5 hours at 58 miles per hour is 290 miles. Go 5 times 58, get 290. 5 hours at 48 miles per hour is 240. Yeah, sounds good to me. They didn't ask us that. They just wanted the speeds, and we got it. So 48 and 58 regarding that. 10. Write the number, 703,015 for number 10. Might as well keep this up here for a second. $703,015. 703,015. 703 got me to the thousands place. 703, all of these are thousands, 15. 703,015. That's 10. Round to the millions. Round to millions for this thing right here. If you take 0.07, now don't go significant figures or anything on this thing. Take this thing and square it, you're going to get a pretty crazy answer. It's going to be a number. The way they got the number is 006, and we can do this in person for the class that is in person. And there's probably a whole bunch of other stuff that goes here. Unfortunately, I don't think I have a calculator with me. But I could maybe actually do something. Point 0792 squared, and what you're getting is, before you do the round off, you're getting 0.006 27264. 0.006 27264. Tenths, hundredths, thousandths, 10,000s, 100,000s, millionths. This is the millions place. Look what's going on right next to it. Let's try it again. Tenths, take a walk. Tenths, hundredths, tenths, hundredths, thousands, 10,000s, 100,000s, millions. So that's the millions place of this long answer, I guess you could say. That's the millions place. Is it going to stay a 2 or go up 1? Well, right next to it is a 6. If it's 5 or more, it goes up, so it went up to a 3. And that's where we're getting. That's to the nearest millions. So 3 is pretty important. So that's 11. 0.006273. Uh, 12. Convert to a fraction in lowest terms. Well, that's pretty interesting stuff. How this whole thing's going to play out regarding that. Let's see what we can say. Again, this whole idea of percent is interesting. The word percent betrays a lot and helps us look at things. I mean, the power of language is very significant. And, the origin of words and how things look and what we can say. right, guys. It's a good amount of things being said, I guess you could say. The word percent means per century or per cent. You know, how many cents are in a dollar? How many cents are in a dollar? 100 of them in a dollar. How many years in a century? 100. In ancient Rome, a centurion was a commander of 100 soldiers. In Greek, it's a ekatondarchos. That's where the word hecto comes from. But both languages were spoken, Greek and Latin, in the Roman Empire. So, but looking at it from the Latin base of century, of cent, centurion, century, cent, cents, all 100 cents in a dollar, 100 years in a century. A centurion commands 100 soldiers. Per cent is per 100. Any real number over 100 is X percent. If I say to you 35%, it means 35 per century. The bar means divide. If you divide by 100, you go 2 places over. 1, 2. You can write it like this, like this, like this. This, of course, reduces to 7 over 20. If you take 7 divided by 20, you get 0.35. If you get 0.35, go 2 places over and call it a percent. If you got a percent, walk 2 places to the left and call it a decimal and get rid of the percent notation. Go 2 places over to the left and call it a decimal, no percent. Or if you got a decimal, go 2 places to the right. So decimal, go 2 places to the right, call it percent. Percent, go 2 places to the left, call it a decimal. And it's looking good. When they say to you, when you're solving percent problems, like when they say generally, when they say what, the word what means X or Y or Z or something. What means something unknown. Is means equals. Of, very, very often, means multiply. You're trying to interpret certain problems that you're trying to solve related to some of this stuff. So it's pretty interesting. Let's talk, I guess you could say. Let's look to problem number 12. Convert to a fraction in lowest terms. 20% means 20 per century. 1 times 20 is 20. 5 times 20 is 100. There you go. That's 12. Convert to a decimal for number 13. 0.65. Convert to a decimal, 0.65%. Take a walk to the left. 1 over, 2 over. That's it. So we're looking good. 12 and 13, there they are. 14. Convert to a percent. Based on what we've been talking about, guys. Don't overly read too much into this, but make sure you got it right. Convert to a percent. Uh, 0.0425. Take a walk. 1 over, 2 over. to the right. There it is. That's 14. 15, convert to a percent. A lot of ways to go here. Probably your easiest bet, much of the time. That bar right there in the fraction means divide. 3 divided by 10 is 0.3 or 0.30. Take a walk to the right, and you're done. Same thing here. 15. 16. 16. An ore, 16. An ore contains 0.8%. An ore contains 0.8% uranium. How much uranium is in 2,000 kilograms of ore? How much or what amount of uranium is in 0.8% of 2,000? What amount of uranium is, means equals. Remember we said that over there. What amount of uranium is present? What amount of uranium is present if 0.8% of the ore, which is 2,000, is right here? All right, guys, let me just make sure it's pretty visible here. I can maybe write this a little bit bigger somewhere. I'm probably going to write this somewhere else a little bit bigger, guys, if you don't mind. So for 16, you guys, let me kind of, just in case it's not, it's hard for me to see what's easily visible on film or not sometimes. Basically, they're saying what amount of uranium is present. What amount of uranium is present if 0.8% of an ore of 2,000 kilograms will give you the amount that's present? In other words, what amount of uranium is present? The amount of uranium is 0.8% times 2,000. Percents are useful to visualize a problem. They're practically useless to solve one. You got to convert it to a decimal or into a fraction. Either way. 0.8% is 0.8 over 100, or you can make it 0.008. You can move over. A lot of ways you can go here, guys, but there it is. Well, the 100 cancels into here 20 times. At the end of the day, it's going to come out to 16 kilograms. And that's, let's make sure it's there. Yeah, right. Fantastic. That's 16. That's 16. 17. In making 260 kilograms of a bronze alloy, 223 kilograms of copper are used. What percent of the alloy is copper, rounded to the nearest tenth of a percent? Well, okay. They're playing games with us again, and that's part of the mathematics. 17, in making 260 kilograms of a bronze alloy, 223 kilograms of copper are used. So you're using you're using 223. You're using 223 kilograms of copper. You're using 223 kilograms of copper of the 260. 260 is the total. 260 is the total. 223 is the amount that is copper. What percent of alloys? Just divide this, get a decimal, round it to the nearest tenth of a percent. So the way that goes, okay, guys, I should bring a calculator. I think I might have a calculator in my office, but I don't want to go there, guys. I think we could probably just keep flowing. It should be all right. So you go 223 divided by 260. Yeah, and it's out there. I mean, there's a lot there. They want it to the nearest tenth of a percent. Now you got to be careful. My advice to you is always take the decimals really, really far out and then do the round off as appropriate, just about no matter what they're telling you. 0.8576, 0.8576, 923. Okay, I'm probably going a little too far on that, but all right, when you're looking at that, guys, all right, guys, they want it rounded to the nearest tenth of a percent. Sounds good to me. I mean, round to the nearest tenth of a percent. Now, you don't do the tenths right here. Get the percentages first. Go 1 over 2 over. You got 85.76923%. Once you got the percent, here's your tenth of a percent. Does that stay a 7 or round up to an 8? You know it's not going to stay a 7. $85.8. 85.8%. Where is that? Now that would have been problem number 17. So yeah, right. 85.8%. There it is. Okay. Not bad. Let's go 18 through 22 and see how we're gonna take care of this. Some pretty fascinating problems, guys. Pretty challenging. They're not excessively difficult, but there are challenges associated with them, and that makes them worthwhile. Because when you know this, you have much in your repertoire to be able to attack various problems that can occur that are of a mathematical nature. Okay, let's keep going and see where we can be. Okay, let's see what we can do. For number 18, it's a great problem. For number 18, how many liters of 20% alcohol solution must be mixed with 12 liters of a 50% alcohol solution to get a 30% alcohol solution? That's pretty interesting. Let me look at it a little bit. So, how many liters of a 20% alcohol solution must be mixed with 12 liters of a 50% alcohol solution to get a 30% alcohol solution? It's pretty fascinating, actually. Very, very interesting problem. Well, let's do it vis-a-vis volume. Let's say all the masses all the masses are associated with equal densities. All the densities of everything are of equal density, let's say. So let's make it more or less the volume, the volumes are proportional to the amount of mass present in association with density. And let's say that all the densities of all the liquids are all equal. All the densities of all the liquids are all equal. How many liters of a 20% alcohol solution must be mixed with 12 liters of a 50% alcohol solution to get a 30% alcohol solution? I've got a 20% alcohol solution. That means 20% of it is pure alcohol. So 20% pure alcohol. How many liters of the solution? The solution is 20% is 20% density in a sense. So let's see what we got here. See how I want to look at it. 20%. How many liters? I don't know. I don't know how many liters that would be. How many liters? We'll call it X. How many liters of a 20% alcohol solution? X liters of solution times 20% will tell you how much pure alcohol is present. 50% times 12 will tell you how much pure alcohol is present there. And the pure alcohol at the end is going to be 30% times X plus 12 because it's a solution together. This is a fascinating problem. It's got to be viewed correctly, however. Here's how you view it correctly. There is a solution of 20% alcohol. That means 20 parts pure alcohol to every 100 parts of solution. For every 100 liters of solution, for every 100 liters of the alcohol solution, 20 liters are pure alcohol. For every 100 liters of the alcohol solution here, 20 of those 100 liters, 20 out of the 100 are pure alcohol. Here, 50 liters out of 100 are pure alcohol because of the 50%. Here, 30% out of every 100 liters is going to be, so 30 liters out of every 100 liters are going to be pure alcohol. Well, there's pure alcohol in this situation, pure alcohol in that situation, and at the end there's pure alcohol. The amount of pure alcohol has to be the same on the left as is on the right. So 20% of this will be pure alcohol. So it'll be 0.2. You've got to convert away from percentages. They're useful to visualize a problem, kind of useless to solve a problem. And this one's 0.5 times 12. And this one's 30% times X plus 12 because you're adding them together. This is the key to the whole thing, you guys. Now we're not done, but you gotta, by hook or crook, you gotta get to this point right here. And that happens if you look at it initially like this. Okay. Well, let's mess with this. It shouldn't be too bad. 0.2x, 0.5 times 12 is 6. 0.3, here we go. Distribute that. 0.3x, 0.3 times 12 is 3.6. Sounds good to me. What you got there is 0.2x plus 6 equals 0.3x plus 3.6. A lot of ways to go, guys. I tell you what I'm going to do. Let me subtract 3.6 on each side, or add a negative 3.6 on each side. It's going to be 0.2x plus 2.4. 0.3x. That's 0, so you got here. It's an important place to be. let's subtract 0.2x. Let's subtract 0.2x on each side. Point 2x minus 0.2x is nothing. You got 2.4 right here. 0.3x minus 0.2x is 0.1x. So you can call it, maybe it's a little easier to have the letters over on the left. That doesn't matter. But you're already here. Divide by 0.1 on each side. Well, according to this logic, 24 liters. 2.4 divided by 0.1, that's it. $24 liters for that. So it's you know, we got to watch it. As I said, guys, sometimes these are easier to solve than they are to explain. Let's make sure that we explained it right. Yeah, and it's 24 liters. I put L, the symbol L for liters, but you can write out liters as well. You can write out the liters as well. That's 14. 19. So that was 18. 19. If 1 pound is equal to 453.6 grams, how many pounds are in 1,000 grams? Round to 1 decimal place. Okay. It is the idea of proportion. When you set two ratios equal to one another, when two ratios are equal to one another, they're called a proportion. A ratio is, a kind of a glorified fraction, I guess you could say. And if you set two fractions equal to one another, you got a proportion. When you set two ratios equal to one another, you got a proportion. So how are they doing this? How many pounds are this? Well, there's a lot of ways to write this, guys, so let me try to make it make a little bit of sense. Every pound is, every pound is 453.6 grams. So 1 pound is 453.6 grams for our purposes. Therefore, how many pounds in 1,000 grams? You can put the pound here and the gram here, or you can kind of just, as long as you know who's who. I mean, 1 pound for every 453 points. 1 pound, pounds per grams, pounds per grams. There's other ways you can do it as well. You can convert. You can compare pounds and pounds and grams. You can do a number of things you can do here. Or you can kind of mix it up, but the proportion, there's a lot of ways to write a bad proportion, a proportion that's wrong, and you're going to get it wrong, But here, let's just say this. Every 1 pound has 453.6 grams in it. How many pounds are there if there's 1,000 grams being considered? Well, this thing's more than double what that is. This should be more than double what 1 pound is. Tell you what, let's do cross multiplication. 453.6 times x. 1 times 1,000 is 1,000. Okay. X is equal to whatever this is. Round it to 1 decimal place. We'll figure it out. Okay, we got okay, that's way overkill, guys, but round it to 1 decimal place. Here you go. There's a 2. Is it going to go up any higher? No, actually not. X is going to be 2.2 pounds. Anybody into weightlifting probably knows that, 1,000 grams is 1 kilogram. Every kilogram is roughly 2.2 pounds. And you're talking about that. It's 19. 20. The distance d traveled by a car is directly proportional to time. It makes sense to me. If my car is traveling at a particular speed all the time for a particular journey, if I travel for double the time, I'm going to travel double the distance. If I travel for 10 times the amount of time that I had done yesterday, I'm going 10 times the distance, all other things held equal. Number 20, the distance d traveled by a car is directly proportional to time t. If small d is 170 kilometers when t equals 2 hours, find d when t equals 5 hours. Well, that's kind of neat. A number of ways to do the proportions, you guys. There's not one way to do it. There's a number of ways. One way to do it is this. If I'm going 170 kilometers in 2 hours, if I'm going 170 kilometers in 2 hours, how far am I going in 5 hours? Well, that's pretty interesting. A lot of ways you can play it. Here's one way. I'm going 170 kilometers in 2 hours. I'm going X amount of kilometers in 2.5 times that. 5 is 2.5 times longer distance. It's 2.5 times longer time frame. 5 divided by 2 is 2.5. If I'm going 2.5 times, if I'm driving for 2.5 times more, or if my time is 2.5 times what your time is, I've got 2.5 times the time travel. I've got 2.5 times the travel time that you have. I should go 2.5 times the distance. It's kind of interesting. You could also say, well, Jim, what are you talking about? Well, I'm saying this. I don't know how far I went. I do know how far you went. I'll say mine's a long distance because I'm going for 5 and you're only going for 2. I'm going to go 2.5 times the distance that you go. It's going to be bigger by a factor. It's going to be larger answer. It's going to be an answer larger by a factor of 2.5. I went long distance, you went short distance because I went long time, you went short time. Both of these solve the problem perfectly. Big divided by small, big divided by small, and they're equal. A lot of ways to go, guys, when you're doing this. Divide by 2 on each side, right? That's it. You're done. Look at this carefully. I know they're two different proportions. That's 2x. That right there is 850. Congratulations, it's the same thing. It doesn't matter which one you do. I went 170 miles in 2 hours. You went X miles. I went 170 kilometers in 2 hours. You went X kilometers in a time frame that is 2 times the size of what my time frame was. You ought to be going 2.5 times what I did because your time frame is 2.5 times more. It all works out. Set up, and it's the same answer, guys. It's going to be the same answer when you work it out, obviously. It came to the same thing over there. 21. Right, 21. The pressure P of a gas varies inversely as the volume. The pressure P of a gas varies. The pressure P of a gas varies inversely as the volume V. If P is 4 kilograms per square centimeter, when V is 15 liters, find P when V is 10 liters. All right, I don't want to get into all the physics of this. Let's just kind of believe what they said. And, let's draw some conclusions as we need to do so. you know, 21. The pressure P of a gas varies inversely as the volume. So what does that mean? Well, if you take a particular sample of gas with a particular amount of moles or number of molecules, and you don't change that at all, and you don't change the temperature remains constant, let's say. Well, there's a lot that can happen here, actually. I don't want to go too far into this, but let's say we were talking about the temperature of an environment. Let me not delve into, because there's a number of ways we can be asking questions related to this, I guess you could say. But let's not open up that can of worms. Let's just say this. Yeah, I don't know how far I want to go with some of this. There's the universal gas law. I'm just going to mention this. This is the number of moles. That's a constant. This is the temperature in absolute temperature scale. This is the temperature in the absolute temperature scale, Kelvin. This is a constant. This is the number of moles, which is like amount of content. This is P. This is V. There's no easy way to write this. If the temperature remained constant and the number of particles remain constant, then this right here is a particular constant. So in other words, you could say P times V is some kind of a constant, which means P1 V1 equals P2 V2. If that is the case, you can divide by P2 on each side and get this. V1 equals V2. You could solve it like that. You could divide by V1 on each side, and you could get P1 over P2 equals V2 over V1. Okay, this is kind of where they're going with this. This is kind of the big thing. this is not an easy thing to discuss. It's probably better done in person for the basic physics classes that get taught, and in the basic mathematics that can be spoken about as well. But there's a big move right there. Notice how this plays. Okay, well, if it plays that way, if you do cross multiplication, you're back to square one, which is okay. There's nothing really wrong with that either. Well, let's see how this plays out. If you do the cross multiplication, guys, you're getting to this. You're getting to a P1 V1. You're getting to a P2 V2. And if the pressure is this, the 4 kilograms per square centimeter, and V is 15, 4 kilograms per, just forget the units as long as we know what the units are at the end. P is 4, some kind of unit, and V is 15, some kind of unit called liters. And they're saying here, find the pressure when you make the volume smaller to 10, find the pressure, P2. Divide by 10 on each side, and that's going to be this divided by 10. That's 60 divided by 10. It's going to be bigger. It's not going to be 4. It's going to be, according to their units. So let's see where that's at, and that's how it plays. You could play it that way. There's a number of ways you can go to get this to happen. You could have stayed here and gone for it. You could have made one guy, you don't know what the P... Call anything you want, but just be consistent. Let's call P1 the small one. Or let's call it the initial one they gave us, and we don't know what that is. You could have taken this guy, P1 is 4. Don't know what P sub 2 is. V sub 2, they're telling me was smaller. It went to 10. V sub 1 was 15. And there, just do the cross multiplication and solve. And you're getting the same solution that we had earlier. A little bit of an interesting problem. You don't need, at this point, to have this, memorized. If you're in any of my physics classes, you do want to have that memorized and be able to work with it. It's a good thing to know. Any science you take, if they're going to talk about thermodynamics and pressures and temperatures, temperatures are so often expressed in absolute temperature scale. That T only works when you're dealing with absolute temperature scale. You've got to have a base of 0 somewhere. Okay. All right, that was 21. 22, the power P in an electric circuit varies jointly. Forgive me here. Okay, the power P in an electric circuit varies jointly. It's with its resistance. So it's spoken kind of maybe I'm not following this too well. For 22, the power P in an electric circuit varies jointly with its resistance R and the square of its current I. If P is 180 watts, when I is 3 amps and R is 10 ohms, find P when I equals 5 amps and R equals 10 ohms. Okay. Great problem. I think they were missing a particular word the way they asked this thing, but that's not really too much of an issue. See what we can say here. It should go pretty smoothly. I should be able to go right here and do it. So for 22, so power, call it the I squared power loss. I equals I squared times R. And that's where they're playing the game, guys. So a number of ways you could play it. If P is 180 watts, when this is so, let me just kind of try to figure out what they're doing. Yeah, okay, it makes sense. So they're basically saying, there's a lot of ways to go here. I think you want to see a proportion somewhere. I'll tell you what I'm going to do. if they're saying this is the power, if the power is 180 watts, when I is equal to 3 and the resistance is equal to 20, if you square 3, you get 9. 9 times 20 is 180. Okay, that's pretty consistent. If that's the case, find what P is if the current is 5. Let's see here. If the current is 5 and the resistance is 10. Square this, you get 25. That's 10. The P under consideration is 250 watts. Number of ways you could have played this. I mean, it's a number of ways it could have been played. You could have said, well, what's the second scenario? Well, it's I sub 2 squared times R, times R sub 2, and then compare it to I sub 1 squared times R sub 1. I don't know what the power is here. I know it's 180 right here. At that point, you could plug in. You could plug in some stuff. You could plug in all that stuff and get 180 on the bottom, and then this thing on top, plug in, you get 250, and the 250 would have been. It doesn't. This is kind of a way to go. I don't want to go down this path. I think this is a better way to go right now. If we need to talk in person, we'll definitely do so, guys, especially for the classes that I'm directly seeing. So we can kind of look at that. Sounds good. Thank you for your time, everyone, and we'll see you soon.